Okay, today we're going to begin talking about transformations. The first transformation that we're specifically talking about, instead of talking about the generality of transformations, is rotation. And so today we hope to define a rotation and provide basic properties of a rotation. So students should know that rotations preserve lengths and segments and degrees of measures of angles, and students should know how to rotate a figure in a given degree around a given center. In the beginning exercises, it says let there be a rotation of d degrees around a center O. Let point P be a point other than O, and select D so that D is greater than 0. And what they mean by D is the degrees that we're rotating around a point. So this really is addressing the objectives. Students know how to rotate a figure in a given degree around a center. And so as I look at this, probably the best way to start learning about transformations in general idea and concept is with transparencies. And so in essence, you have like this clear sheet of plastic that you can draw on with markers, and it kind of lets you visualize what's going on. Now there are some important details to the directions here, and I highlighted them, that D is greater than 0. And so what I'm going to do is I'm going to rotate everything from point 0. And what I like to do is I like to actually put a point right there, and it allows me to freely spin around that point, which makes a really nice system so that we can see it. And so here again, I'll start off, I put my pen right on point O, and it allows me to rotate this around. And so I have actually right now rotated this in the direction of a positive D. So here's your pre-image. And the resultant of that rotation is your image. And the direction stated that we needed to have a positive D. And so what I want to point out is that with a positive D, we actually rotated the image. This is counter to what you would expect, but counter clockwise. And what this stems from is the way we orient our coordinate graphs. This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. And if you're starting off 1 to 2 to 3 to 4, it works in a counterclockwise direction. So I want you to pause. I want you to write this down, that if I have a degree of rotation greater than 0, I work in a counterclockwise direction. Okay. The other side, if I want to work in a D is negative rotation, there's D is negative. And so I worked this way, this being my image, this is the pre-image, it's the original. I worked in a negative D less than 0 direction. And again, if you're working from a coordinate graph, here is 0, here is 90, here is 180, here is 270. But the other way to look at this is going in the clockwise direction. And so this would be negative 90 degrees. This is negative 180 degrees. This is negative 270 degrees, and so on. Again, please pause. Make sure you clarified this, writing down the image that we're working with, writing down the little graph, making sure you understand that if the degrees that you're rotating is less than 0, then you're working in a clockwise direction. Just to continue making sure that we stress this for you, it says which direction did the point P rotate when D was greater than 0 in a nice complete sentence. Point P rotated in a counter clockwise direction when D is positive. Point P rotated in a clockwise direction when D is, or really it should be grammar-wise, was negative. Okay, so that addresses students know how to rotate a figure given a degree around a given center. So everything hinges, the criteria is a rotation point and then the number of degrees that make up the angle. Okay, so to build some understanding of what's going on with this, we have another image here with a figure. It says let L be a line, or so L is a line, AB is a ray, CD is a segment, angle EFG is the angle, and it should be rotated around point O. Find the images of all the figures when D is greater than 0. And so let's first just kind of copy these down. And so this is a line, so I'm going to add the arrows. Here's my angle. Here's my segment. There's my point O. And here's my ray. Okay, I'm going to put my pen, I'm going to rotate it in a positive direction. And it would look something like this. And so this would be E prime, F prime, G prime, C prime, D prime. Oh, notice stayed on O. There's no change there. This would be A prime, and this would be B prime. And so hopefully you're getting a sense of how this works, how the system of having rotation works, and you just kind of keep rotating it around. Another thing I'd like to point out is even if I bring it back to the exact original spot, look how the angle lines up exactly on top of the angle. Look how the line segment lines up exactly on the line segment, and the ray lines up exactly between the points. Okay, so keep that in mind as I show you the next example. Because we have specific questions that we're going to look at following this. So I pre-did this. Here's my point O. I have an angle of 45 degrees. I have a line segment of 4 units. And so let me get the directions on here. And it says, let line segment AB be a segment length 4 units and angle CDE as an angle of size 45 degrees. Let there be a rotation by D degrees where D is less than 0 about O. Find the images of the given figures, and answer the questions below. So I'm going to put my marker or pen right on there, right on O. Let me make sure these are lined up originally. And here we go, rotating in a clockwise direction. I can see that right now I have A prime, B prime, D prime, C prime, and E prime. Now some of you might be wondering why this didn't just like D prime stay directly on D prime. It has to do with the distance between your rotation point and your original point. And so if I were to have plotted this, this actually acts like a circle. It's just a rotation in a radius. And so that might help you guys kind of make meaning of what's going on. Now again, look how these images are rotating left. If I continue this in the negative direction, it just keeps on moving in sort of a circular movement. And I bring it back to the original. I want to point out, notice how it lines directly back up on top of the line segment, which is 4 units, and the angle. And even if I move this transparency out of here, notice the degrees, they didn't change. They stayed 45. The line segment, 4 units. Okay? And this is a